Hey peeps, it's Julian here from Tutoring, and as always, it's such a pleasure to join you. Today we're continuing with the IEB 2019 Math Paper 2, the supplementary exam, and we're on question number 4, which continues to deal with trigonometry. So question 4a number 1 is proof that sin theta over cos theta minus sin theta plus sin theta over cos theta plus sin theta equals 2 sin theta. It's quite a mouthful. But with a proof question, you always need to split it out into left-hand sides versus right-hand side. So we know that your left-hand side will be that big 2 terms there, and your right-hand side that we need to prove it will remain constant as your 2 theta. So to start off, we need to find the lowest common denominator for your left-hand side. So in this case, it will have to be the 2 denominators multiplied by each other. So that's going to be sine or cos theta minus sin theta times cos theta plus sin theta. And we'll then on top need to, so what was missing from the first term was a sine times cos theta plus sin theta. And from the second term, which is plus, it also had a sin theta, but obviously from the denominator was missing a cos theta minus sin theta. So then moving on, separate that this is your right-hand side and left-hand side. So we can multiply this all out. So it's a sine theta cos theta plus sine theta squared, because we multiplying the sine into those two terms, plus, again, we're going to now multiply it into these two terms. So it'll be sine theta cos theta minus sine theta squared all over, and this is just your basic FOIL. So it's term 1, which will become cos theta squared, and then your inner terms, which is your minus sine theta cos theta, your outer terms, which becomes a plus sine theta cos theta minus sine theta squared. Cool. So moving this on, we can see that this minus sine theta squared and plus sine theta squared will cancel out. And these are like terms left at the top. So we've got that it's 2 sine theta cos theta all over. And again, these two terms cancel out. So we've got cos theta squared minus sine theta squared. Okay, this is actually then found in your formula sheet, which is sine of 2 theta, straight from your formula sheet, and the denominator is also in your formula sheet, where cos squared of an angle minus sine squared of an angle equals cos of 2 theta, and we know that sine over cos is tan of that angle, which is 2 theta, which equals your right hand side. So therefore left hand side equals right hand side, and that is the answer for A1. Question 4A2 now saying, hence determine, correct to one decimal place, the general solution for theta for these two terms that we've just proven equals tan of 2 theta. Which will make this a lot easier, because if that equals minus 5, we do the normal general solution procedure, which means we need to find the reference angle, which we know is the now arctan of, which is tan to the minus 1 in your calculator, shift tan, of minus 5 over 1, which I get in my calculator to equal minus 78.7 degrees. Of course, refers to the tan of 2 theta, so therefore 2 theta equals minus 78.7 plus k times 180 degrees. Because remember, tan repeats every 180 degrees. So if we then solve for theta, we divide both sides by 2, which is negative 39.4 degrees plus k times 90. And that is your general solution. Cool. Okay, and then we're on to B, number 1. And it's given us that sine 27 equals m. We now need to determine, without the use of a calculator, the values of the following. So first up is, we know as one of the trig formulas is that cos theta squared equals 1 minus sine theta squared. So if we substitute in your 27 for theta, we've got that the cos of 27 squared equals 1 minus the sine of 27 squared. We can then find the square root of both sides, and we're left with cos of 27 should equal the square root of 1 minus the sine of 27 squared. But we know that the sine of 27 is m, so we can say that this equals the square root of 1 minus m squared. On to B2, they've given us sine squared of 63 degrees. So for this one, we need to know our trig formula that sine of theta equals the cos of 90 minus theta. So then if we just put in the square there, this whole thing would also be squared. So then we know that sine of 63 squared should equal cos of 90 minus 63. This is all squared. So we know then that this should equal cos of 27 degrees squared. And then we can use the fact that, as a side note here, that the cos squared of theta should equal 1 minus the sine squared of theta. So therefore we can say that this should equal minus the sine of 27 squared. And we know that sine of 27 is m, so therefore your answer is 1 minus m squared. Moving on to number 3, we have the sine of 72 now. This is a little bit tricky because we need to get this number of 27 degrees out somehow. And now, when you see a question like this, you've got to start to think of your special angles. So this would also equal sine of, and we know that one of your special angles is 45. Plus, this is your 27 degrees that we know we're going to need to make use of. And again, from your formula sheet, we know that sine of A plus B will equal sine of A cos of B plus cos of A sine of B. So using that formula, we know that this will equal then sine 45, which is a special angle, cos 27, plus cos of 45, sine of 27. And we also know that sine 45, you should know this off by heart, is root 2 over 2, and likewise cos of 45 is also root 2 over 2. So we can sub those in for root 2 over 2 times the cos of 27 plus root 2 over 2 sine of 27. Now you should remember from the first question in this section that cos of 27 we calculated to be the square root of 1 minus m squared. So we can now reuse that to substitute it in for cos of 27. So then we know that it would be square root of root 2 over 2. Make that substitution of m of the square root of 1 minus m squared plus root 2 over 2. And we know that sine of 27 is m. And we can bring out the like terms here. So we get a final answer of root 2 all over 2 times square root of 1 minus m squared plus m. And that's the final answer for that one. Moving on to the fourth question, and they're asking us here now to solve for tan of 243. So here we're going to need to use the fact that the tan of theta also equals the tan of 180 plus theta, which we know from, if you ever need to check our cast diagram, we know that if this is 180 degrees, angles in this quadrant, number 3, tan is positive. So therefore, using this fact, we know that tan of 243 will equal the tan of 180 plus 63. It's going to become useful now because we know then that this will equal the tan of 63. And then also using another trig formula, we do know that the tan of theta equals sine of theta over cos theta. So this will then mean that this equals the sine of 63 over the cos of 63. Then we need to use our reflex angle formulas because we know that the sine of theta equals the cos of 90 minus theta. So that means that if we have sine of 63, we know that this is going to equal the cos of 90 minus 63, which is going to equal cos of 27. And same thing goes for cos of theta equals the sine of 90 minus theta. So therefore, cos of 63 will equal the sine of 90 minus 63, which equals sine of 27. So we can substitute those two values. So we know that this will then equal the cos of 27 over the sine of 27. And if we look back at our question number 1, we have that the cos of 27 equals the square root of 1 minus m squared. So we can then finally write then that this will equal 1 minus m squared over m, because of course sine 27 is m. And that's your final answer. That concludes question 4. So before I go, I'd like to say a special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find your answer to the question that you would like to be answered, you can send it to us and we'll respond with a personalized video just for you. And until next time, stay epic.